Now, I'm pleased to introduce our next session, a panel discussion on the topic of mastering speech in search with data-centric NL. Joining us to moderate is founder of TWIML, Sam Charrington. Sam, would you join me on stage?
All right. Hey, thanks, Piyush.
Welcome, Sam. It's great to have you here. I'll give you the stage. Looking forward to it.
All righty. Well, I'll have our panelists join as well while I introduce the session. Again, my name is Sam Charrington, and I am the founder of TWIML and host of the TWIML AI podcast. And I'm super excited to be moderating this session featuring panelists Anoop Sinha of Meta and Braden Hancock of Snorkel. For AI builders, especially, but not limited to those working on large-scale search and dialogue-based experiences, ensuring safety and eliminating harmful content and bias are key concerns. We've got a really interesting chat planned around how you and your organization can apply data-centric principles to attack these challenges today, as well as explore how the approach to safety will need to evolve to face future challenges in light of advancements like large language models. Before we dive in, I want to remind you that I'll be keeping an eye on the Q&A panel, and I've got some time reserved to pull in audience questions towards the end as well. To get things started, I'd like to give our panelists an opportunity to briefly introduce themselves. Let's get started with you, Anoop.
Sure. Well, thanks for having me. My name is Anoop Sinha. I'm a senior applied research scientist manager at Meta. I work in the FAIR research team. And I've been at Meta over the last 6 years working on a variety of different topics, including search and natural language.
Awesome, thanks. Braden?
Yeah, and I'm at Snorkel today. I've been working on this project for a number of years at Stanford originally when the project began, and then now at the company. Before that, and partly during that, did brief stints as part of Facebook research and Google research as well. So glad to be here.
Awesome. So let's dig in. Anoop, you've got a really interesting set of experiences relating to search quality and harm avoidance and how these impact upstream data collection and labeling. I'd love for you to dig in and tell us a little bit about the problem you faced.
Sure. Yeah, and thank you again. So over the last 10 years, I've worked on a couple of major search engines. First at Apple, where I helped introduce Siri search, and then also at Facebook, where I worked on Facebook search for a number of years. One of the key problems for both search engines is to not show harmful content. Both companies have community standards about content and or pages that they do not want to show. And these search engines really need efforts and work in order to avoid showing those. I wanted to focus on that story, around avoiding harmful content by starting out by saying how hard a problem it really is. The upside when you do a search engine correctly and you show something good is there, but the downside of showing harmful content is even more extreme. There's legal issues as well as ethical issues for that other side of it. And the other challenge with that type of content is that it might be engaging to users. So in fact, it actually becomes even harder to identify because it sometimes looks like good content in the stream. And so real key for us was to develop technical systems that have good high recall ability to identify those contents, but we need to really narrow it down to be able to show, to be able to avoid showing that harmful content. The real key to this was humans in the loop. And that's both for setting up the analyses for how to measure harmful content and also the labeling that's used. And that labeling would also be used to develop the systems that are classifying that content overall going forward in order to make this a scalable solution. So I'd like to say this is very akin to active learning and the need to really zoom in on issues that are there. And at the end of it, our hope and our goals were to develop both good metrics and good classifiers for that type of harm.
Awesome. You mentioned active learning and the need to zoom in. And, we often talk about in the context of building models, kind of this idea of class imbalance and making the kind of, and how class imbalance makes the kind of modeling we're trying to do more difficult. But in your case, it sounds like not only do you have the class imbalance, but there's also this disproportional cost or risk associated with surfacing harmful content. Can you talk a little bit more about the challenges that presented and how it impacted the approach that your team took?
Yeah, absolutely. If I think about metrics for search engines, there's a variety of different approaches to it, but a standard metric such as success on clicks or other things would actually hide the issues of harmful content quite significantly, if not actually mix it in an improper way. The real key for us when we set metrics was to stratify our sense of query sets so that we're actually looking disproportionately at harmful content, the risk of harmful content in the core metrics that we set. And so the stratifying the metrics, to just give you an example, may involve looking at query sets that we feel are at risk of showing harmful content and overemphasizing them in the objective function that we're looking for. And it may even be the case that in those query sets that are of risk, we may even find ourselves filtering, the content because there's that much risk in it that we said we're going to completely shut it off. We worked together with the policy teams to make those decisions. In both companies that I worked in, it was very active discussion around the right decisions to make. But it's certainly the case that we need to emphasize harm, in the core metrics themselves. One thing I wanted to maybe give sort of thought about was the hunt. The hunt for harmful content is actually pretty difficult because it's fairly low prevalence in these query streams. In order to do that, we may start with, just give an example, we may start with a set of example queries that we're concerned about, and then look at the results that those queries may show. On looking at those results, we may look at and just do a round trip and look at other queries that may lead to those results. So we're doing this closure set a bit, around the possible risks in those harm sets. And this is giving us a large set to take a look at and examine for harmful content. And hopefully it has the categories of risk that we've got. But we need humans in the loop for certainly, in order to take a look at that. And it's really critical that we use the correct guidelines and the human judgment in order to identify risk or not. And then just to make it an even harder problem, it's a really dynamic threat or a dynamic change, because let's say we've identified and built classification that helps us eliminate a set of harms that we think we've got. Well, the harms may change. The bad actors in the system may be using different content or different queries, as well, in order to just move the problem forward. So this is a challenge that we've definitely faced. So it's a constant effort.
I want to pull in a question from Hiket in the Q&A panel. Did you approach these problems exclusively in a supervised manner, or were there unsupervised elements to the way that you attacked them?
Yep, it's a very good question. And I'd say in the era in which we were working at it, I'd say we highly, highly emphasized supervised methods because we both needed to analyze and understand the threats. As I think techniques have changed and as things are moving forward, one could argue that this closure classification is kind of an unsupervised method, but we still would review it in a supervised method in that case. So I'd like to say during the eras that I was involved, we were quite heavily working with humans in the loop.
Got it. And you've emphasized the humans in the loop several times here. To what degree have you explored machine labeling, machine labeling as a way to help generate your data set and kind of reduce the burden of human labeling? Yeah.
And so with those sets that we're in concern on, there's some cases where I think everyone has their lists of query of terms, of toxic terms, that they're trying to avoid. And so those terms were some things that we would use, right, to say these possible documents have words that we don't want to see. And those could be offensive words or toxic words. And so those were used even then. But I'd say the techniques have gotten a little bit more sophisticated over the last few years about those types of supervision. It's related to the question that came up as well. I think that there's greater opportunities to use more sophisticated models for that. During the eras I was involved, I'd say we were hesitant to do automatic or even weekly supervised methods, because we really needed to take a look at what was happening.
Yeah, yeah. So in our pre-call, Braden asked a really good question, which is around the kind of the need for and the role of iteration in your world. Can you kind of talk about how the project evolved? Where did you start, and how you knew what the right next step was at any particular point in time?
Yeah, and that's a great question. In a certain set of cases, we were at the beginning of introducing either the search engine or a new feature. So at that beginning, very intensive efforts to make sure we were safe at launch. And then there's various cases along the way where there were some critical issues, that we had to address, perhaps in war rooms or just intensive issues to address. But over time, I think we got better, in these techniques, and realized that the real key was to centralize. So we're building, at the end of the day, the measurement was there, but we were also building machine learning, and we're building machine learning classifiers as a deliverable, and those classifiers are getting better, over time. And then in the case of both companies, how do we centralize those classifiers as assets of the company so that they're usable across all sorts of applications? That was really the journey that we went on. And I think that centralization was extremely beneficial because it combined insights from various teams who are working on similar problems into what I'd say right now are at least attempts at really good classifiers for these types of techniques. But there is, of course, an ongoing threat, so they constantly need maintenance and change. So I'd like to say, the core work that these companies have done in this area is full of dedicated individuals and dedicated teams to try and really reduce harm, and that's shown in all the different products.
Awesome. Awesome. Now, Braden, you've come at similar sets of issues from the perspective of dialogue systems and chatbots in particular. Can you tell us a little bit more about that use case and how it compares and contrasts to what Anoop saw in search?
Yeah, there's some definite similarities from the standpoint of both of those scenarios put you in sort of what I think of as like an open world setting where the model, it feels like at least it's generating, new content. With search or ranking, it's technically not generating, but when the space of options is so large, it does feel like it's, making a statement when it returns something. And when you get to doing generation, I feel like the error modes become a little more severe because it feels more personal or intentional, when something goes wrong. So there's extra sensitivity around, what's going to come out of our AI's mouth and how do we control this? And there's different ways of doing that, both in the way of how you train it, what's in the data that the model is going to learn from, as well as in attempts at sort of, post hoc, filtering. Are there ways that we can kind of catch bad things before they get out or remove them entirely? And I'd say in general, historically, there's been more of a post hoc, let's put on post processors to catch these types of things. I think that's still present, but there's increasingly an awareness and push for, making the data up front that things are trained on, reflect the types of, behavior or topics or general, I guess, attitudes that you want to come from your model.
All right, let's maybe back up and have you share a little bit about the scenario that you were working on and the type of chatbot that you were building.
Yeah, so at Facebook, I was working on a project for chatbots to do basically chit chat. They called it. So it was not necessarily like goal oriented, like help me complete this ATM transaction, but more like let's talk a little more broadly around get to know you topics. So again, a very open world, which is tricky. And in that particular project, we were focusing on, in a way, an aspect of control. If we could give sort of some context or a background for the chatbot to condition everything that it said on, so that it could be more consistent with a certain personality or background information. So in that project, there's step one, which is teach the chatbot to sort of speak coherently at all. Two maybe is to speak on topic, and three is say useful and interesting things. And natural language is hard, like to learn how to speak like a human. Obviously it takes years for us to do, either the first time or a second language. And so you need a lot of data for a model to learn to do that as well. And the more data that you use for training, the more chances there are for things you don't want to necessarily teach your chatbot to slip in. And in some ways, that's inevitable when you get to a certain scale, that you can't handpick every conversation for it to learn from. And so that was something that we spent a fair bit of time thinking about and looking into, is how can we get the benefits of training on massive amounts of conversations, perhaps scraped from the internet, but not necessarily, teach our chatbot to be an internet troll, like, help it have better behavior and vocabulary than that.
And so were you fundamentally approaching the problem as one of generating responses, or were you selecting among pre-vetted responses, or a combination of the two?
Yeah, so we experimented with the whole spectrum, and this was a few years ago. So in a fast-moving field like this, I can't speak to even what's being done today, but at the time, on the spectrum of sort of most conservative to most aggressive, I'd say on the conservative side is you can essentially provide templates, right? Let a chatbot slot fill, and you'll see various digital assistants, especially on certain common topics like weathers and sports scores and things, be very rote in the way that they respond, where there's fewer ways it can go wrong because you know exactly the shape of what they're going to say, and they're just filling in the details. One step beyond that would be not just slot filling in a template, but select from sort of pre-approved responses. So in this case, we did have 100,000 or so conversations that had been supervised, had been more meticulously crafted together. And so, the chatbot, when it's time to say something, can figure out what it would like to say in embedding space. In this case, find the most similar example that's been pre-approved and then say that. So there was an element of, we're not going to be surprised by some new combination of ideas being presented. You don't know still what the conversation flow is going to be, so there is still risk there. But in that case, we were using more of a, we'll say, restricted set. But the goal always was, how far to the right can we push this over time? And did begin to do, even as at the end of my time there, some experimentation around ways to control, and even in free form generation a little bit more, letting the bot say, new ideas that had not been seen before, but still with basically its internal barometer for how edgy a response may be.
And one of the ideas that you explored and published on to kind of overcome the cost of collecting labeled data sets was this idea of a self-feeding chatbot. So allowing the bot to extract new training examples from the conversations that it was participating in. Can you talk a little bit about that effort and how it turned out for you?
Yeah, that was a really fun project because my research interests have been for such a long time on weak supervision. Where is there more signal that we can pull in without a whole lot of additional effort? And so we were looking at, we've got specific conversations which we can teach the bot to kind of model after, which is maybe the most direct, like just traditional supervision. But then we figured you spend some time training a model and then you deploy it, and probably 90% plus of a model's lifetime is spent in deployment, not in training. So there's all the rest of this time that a model's being used where it's having conversations. And as a human, you can kind of tell when a conversation's gone well or gone wrong, when there's maybe a misstep and you weren't on the same page. And so basically what we looked at is, can we teach this chatbot a simpler kind of auxiliary task of identify when a conversation is going well, when the user is satisfied or delighted with your responses, or when they're saying, what are you talking about, or I don't understand, or signs that it's not going well. And that became basically another set of weakly applied labels, sort of somewhat automatically applied labels, automatically, but based on this simpler task of just, are things going well or not, as opposed to what should I say, which is a little more open-ended. So by having this model learn from both of these types of data, both conversations as well as telling how well a conversation's going, it ended up actually refining its ability to speak, or at least to understand what conversations should look like. And that ended up resulting in a higher quality chatbot that was rated as more engaging and more on topic and more satisfying to speak with.
Mm-hmm. Now, this was a little bit before the era of large language models, but I've got to imagine that the whole time your team is kind of looking enviously at the corpus that is the internet and trying to think about how you might advance your own systems using all of that information. To what extent what avenues did you pursue there? Or how did you think about that opportunity?
Yeah, I mean, data is it's an old cliche at this point, but data is the new oil, right? It's what runs these systems we're working on. So it was absolutely on our mind of in general, you see that curve. You see that you add more data and your model gets better, and so you're always looking, where can we get more data? And appropriately so, we weren't using internal Facebook data, and so we really was looking more at from the internet, where can we find conversations happening. So there are different places where different forums where chats happen, and you can tell that it's a continuous conversation. That we were planning for chatbots that speak in a one-on-one setting, not like a big group setting. And so you'd look for where similar user IDs had gone back and forth a bit, presumably kind of following through a thread of conversation. And that's the type of skill set you want to teach your model. So we definitely did look and see what we could scrape, where there was kind of open source or readily available conversation like data on the internet. And it did, in fact, as expected. Pre-training on that, you could improve the quality of the model, or at least its ability to understand language. But then what we found worked best was to as is often the case, pre-train on broadly applicable data to learn skills and features in a general sense, and then fine tune on your most relevant data at the end, teaching it more specifically, something that you've got finer control over, that last data set that's maybe more hand curated.
I'd like to open up William's question to both of our panelists. How do you think about balancing kind of this need for scale, both in the systems you're building and in the data sets that those systems require and consume, with the requirements for control in the output of those systems? Why don't we have you start, Anoop?
Sure. And I think it's a great question, with also a really key part of the answer, in my view, in the question, which is balance. These systems have potentially behaviors that really do need to be studied in detail. And if we go back to the case of harm classifiers, we need to understand how accurate they really are. And though I did mention the emphasis on making sure there was good coverage and recall in our data sets, the classifiers themselves have characteristics that we really need to understand in detail. And the precision of those is critical. I'd like to say, in terms of balance, it's a lot of analysis and human judgment, in my experience, that's involved, in partnership with policy teams and other teams to assess, in the case of harm, risk ratios versus the actual harms that are expected, as well as the behaviors of the product. So I think the balance is based off of the requirements of the product in full, and I'm sure that will vary based on different scenarios.
Braden?
Yeah, no, completely agreed with Anoop's answer. The only thing I'll add is, and he mentioned this at the beginning, but iteration is key. There is just no way to anticipate all of the scenarios that you can find yourself in, or all the possible ways things can go wrong. And so the answer, in my opinion, is to have just levers to pull, control over your data, and a cadence where you're able to periodically review and assess how things are going, and then in a scalable way update the behavior of your model. So obviously at Snorkel, one of the things we've invested in is programmatic labeling, with the idea being that it's human driven, but then when it's time to change things, whether that's to add a new signal or tweak an existing one, you can modify a line of code, push re-execute, and regenerate your training set, so that you can pretty quickly and oftentimes significantly modify the behavior of your model by modifying the training set kind of in bulk. So the iteration basically ends up being the key then, so you can be as aggressive as you'd like or can be on how much data you take advantage of, but then have the ability to address error modes when they arise.
Right. We also wanted to look forward a bit in this conversation. Braden, how do you think the growing popularity of large language models will play as organizations try to take advantage of them to build these kind of systems, but still ensure safety?
Yeah, I mean, large language models are such a promising and exciting thread. As people have found, they make this fantastic base to build on. It can basically take advantage, or take care of the large part of basic natural language understanding, or generally relevant features. And then your task as the domain expert now becomes basically just the transfer, helping to identify the relevant pieces of what it knows to your specific problem, or matching your particular goals for that model. So super exciting, and I think in many ways it'll change where the focus needs to be for subject matter expert time on a problem, where a lot more of it can be now on that kind of final mile transfer of how do I map what you know to my problem as opposed to sort of teach you skills from scratch. So I think in many cases it'll make sense to begin sort of your model on that base of a foundation model, and then you'll just need to recognize that that comes with certain biases. And I know there are attempts with different of these large models to help reflect particularly fair or reasonable training data to begin with. I think the Big Science workshop that we've participated in as well, and been part of publishing some of that work over the past year, has led to some, we'll say, very intentionally built foundation models where there was a lot of attention paid to what data is going to go into this, and what kind of skills do we want these models to have, including performing well on multiple languages or different things like that. So there's no easy answers here. There's a lot of open research questions. It's obviously hugely on the mind of the research community right now, but there's a lot of exciting potential directions it can go.
Again, for you, Braden, pulling in a question from Vashish, do you think that large language models might be part of a solution to handling the long tail of customer responses with chatbots that are traditionally really hard to replicate?
Yeah, I mean, that's an area where you definitely see the benefit of going into, we'll say deep learning land, because once upon a time, chatbots being much more templatized, look for, depending more on discrete signals, specific words, specific, paths. As soon as you get off track, you're quickly, don't know what to do. Whereas, with these large language models that have seen so much data, they often have a much, what I think of as smoother understanding of the space. And so a word they've never seen before, or have seen very rarely, there's still often enough of a similar embedding or context or whatnot that they can do pretty reasonable things. So it definitely helps a lot. That's the benefit of moving to machine learning from, we'll say, a more rule-based world, is that you get the benefit of a lot of generalization and smoother decision space as a result.
Anoop, what are you seeing with regards to the role of foundational models and LLMs in the context of the types of systems you're working with?
Yeah, I think it's a strong role in the future with a lot of open questions at the moment. I'd like to say I think the industry is rightfully moving cautiously in terms of putting large language models into production. There's a whole set of issues that need to be studied. My guess is we end up with large language models, fine-tuning, and a set of additional models as an aggregate that actually lead to safe systems that have higher capability.
Fantastic. Well, I'd like to thank our panelists for a wonderful conversation and thank our audience for contributing some great questions. And at this time, we will turn it back over to you, Piyush.
Awesome. Great panel and great discussion. Thanks so much, Sam, Anoop, Braden.